Hi guys, welcome back to our channel. So today we are back with a new video on a specific topic. So have you ever thought about any feature which you are using day in day out and don't know how it gets developed as a developer or as an architect? So now it's the time to think about it. Now it's the time to think about the scale and the performance of that feature as well. That feature is nothing but the continue watching feature. You may have seen this feature in different OTT applications like Hotstar, for which we are doing this video, or Hotstar is not endorsing this video, but the entire series or this series, few videos are dedicated to the Hotstar engineering work that is going on, but not for Hotstar. You may have seen that feature in other applications also, like maybe YouTube or maybe Amazon Prime, Netflix, or any other OTT applications that you use. So you may have come across the scenario like you watch some video to some time and then you pause it and then you watch it on other TV or on other system. Or you may watch multiple episodes, and when you go on to other client or when you go on to, let's say, from your mobile to your desktop, you watch that similar series next episode, or you continue the same episode from where you left from the previous device. So you may have seen these kind of basic features in all these applications, but today we will see what were the challenges or how Hotstar tried to build this feature from scale 0 to scale pretty high. Now, we are representative of digital needs. So today we are back with a new video on the scale of the continue watching feature, how Hotstar scaled that feature, how Hotstar identified the challenges in that feature technically in their infrastructure, how they mitigated those challenges by figuring out the alternate architectures, and how they went on refactoring, or I would say replatforming their architecture of that feature from one place to another. So let's dive into it. Let's get started. So on the first diagram, I am talking about the write feature. So let's talk about write first. So whenever you are watching a video, whenever you are watching an episode of a series, so you have multiple clients. So client A can be your mobile phone, client B can be your let's say desktop or anything else. Client C can be anything else or any other mobile device, for example, where you have logged in into Hotstar. Now you started watching the video from client A, and then you started watching into client B, and then you started watching into client C. So you started watching from client B from the instant where you left the video in the client A, or let's say you left the video at second minute in your mobile device, and then you continued the same video in your desktop from the second minute only. So this is a very useful feature, right? So now we will see what were the challenges or how Hotstar initially built that feature and how they identified the challenges in that feature. Now, all those clients are talking to the Hotstar interfaces or Hotstar application. Now, whenever you watch the application or whenever you watch any video or anything on Hotstar or any other platform, for example, so it keeps on sending an event to the Kafka producer. Now, we are talking in context technically here only for Hotstar. So, Amazon Prime may have different tech stack, but let's talk about only for the Hotstar context. Now they had a Kafka event listener, you can say, where all the events were coming from all the clients via Hotstar APIs and all while they were watching the videos. Now, as you can understand, there is a huge scale of Hotstar users today in the market. There are more than 100 million plus users across the globe, or maybe more than that. So, considering that much scale users and to give them this small feature is a game changer. Now, if you think of very small users, let's say I have 10 users only. In that case, if I have to retain the continue watching feature for those 10 users, then you may not need to spend so much of time and effort. You can directly go and build an API that will store a data in a data model or in a database. It can be SQL database, it can be no SQL, then you can query it out of that table also, and then deliver the content to your users. So it is pretty simple. Use a database, use an API, and even if it is having lot so many calls, but you don't have a huge user base, so you can still withstand with your infrastructure. But that was not the case with Hotstar. Hotstar has millions of users and it is growing also. We need to understand that. You may have heard about the stories of Hotstar, like they endorsed India New Zealand match in 2019, and its viewership had gone until 25 million users in that match. And then after that, they endorsed different IPLs and different other live matches for which the users growth happens a lot. So as you see, Hotstar is also a growing user base, has a growing user base as well. So its user base is not only till 100 million. If you think of it is stagnant. So that is another point we have to think in the mind. So whenever you are building in an engineering product company like Hotstar, you have to think of scale at the first, because as I explained you about in this example, scale is the key. Scale is the game changer of your architecture. That is what the most architects strive to build for. So now coming back to this architecture after the Kafka. So Kafka used to send the events to Elasticsearch and the Redis. So Redis, it is a NoSQL database, as we know, and Elasticsearch has an index techniques. So whenever, let's say, if I am watching a video on client A, some other user is watching on some other clients or whichever clients they have, so they will keep on sending the events to Kafka, and Kafka will keep on sending those events or storing those events to Redis and Elasticsearch clusters. The event size was also not small; it was also huge as the time was passing by, and they had to store that humongously on different uh, systems of Redis, and they had to scale also, as I was mentioning. So then they had identified a problem that every 3 or 4 months their user base is gradually growing up very well. So they had to add more horizontal scaling clusters, so with which their scaling of, let's say, performance or scalability aspect was still coming in control. But the downside was their cost thing was going on because they had to add more clusters for Redis and Elasticsearch to withstand the load that they had. So that's where they were having a challenge in scalability, and at the same time, they were adding more cost to it also. That's what they had to support as well. So this was one of the major challenges that they were having. Now we will come to the other side of that picture. So now when you are reading it, so now let's say I have watched a video, now I have to read it from the other client. I have to see the continue watching series or the continue watching list that I have. So I'll go again, go to Hotstar, it will go to an API. API will talk to both these systems and get the data out of it. And then it will convert the data and give it to my respective, how I can see the data of continue watching in my app. So based on that, it will convert that data. Now, another thing which we need to understand is the data model. Data model of Elasticsearch and Redis, how they were storing, that was different, and they had to support those data models also while they were converting back to the while at the reading time as well. So this was another challenge that they had to support as well. Now, what are challenges we have talked about till now? Let's list down them first, and then we will come to the next point. So first is your scalability in terms of users. Scalability of users, and then is your cost of infrastructure, which was rising. And now I'll talk about the third one, which is the latency. Now, if we talk about when you are fetching the data from Elasticsearch and Redis, so there is a understandable amount of latency also uh, tied to it. Now, if we talk of Elasticsearch, now what kind of data or how much data do you think their clusters can have? It was around in TBs. I don't remember the exact number, but let's say it is in tens of TBs. Now, the same number, let's think of how much Redis would have. So Redis would have around 500 GBs. So now think of this much of data scale and think of the performance, how they delivered to it. So this was, and this was gradually increasing. To add solve to this problem, there was a latency issue in either or in both of them, in Redis or let's say Elasticsearch, as the data was growing on, and they had to horizontally scale their infrastructure to support the performance and scalability factors. But till how much time they could support it, because the cost was rising and they could not support it for a longer duration. So they had to come up with an alternate solution. So they had come up with a solution of a NoSQL DB, where you would add only two tables. One is the users table, other one is user content table. Users table is where you store the data related to what all videos you are watching in the continue watching list. Now let's say while I'm on the OTT platform, I watched first video, I left it. I watched it for 5 minutes, I left it. Then I went to a web series. I watched the first episode, or let's say nth episode, for 10 minutes, and then I left it. Something like that. So if I keep on doing on this OTT platform, so I'll have n number of videos which I'll watch, but I'll leave also those videos in between after some time. So which means I'll have long list of continue watching videos as well, but that list has to get updated also as and when my videos are finished as well. So let's say if I watched a video today of 2 minutes, which was total of 10 minutes, but then when I watch the video completely of 10 minutes on any other devices that I have, so then it has to go away from my list, so it has to get deleted from my continue watching list. So that thing also has to be maintained. So that's where they thought of keeping their data model simple and thinking of a scalability aspects as an architect. So users table, in this users table, they would store the user and their videos which they are watching, or let's say I would say only the users and their master information on what all or how many videos they are watching, something like that. Videos are in continue watching, something like that. Then in user content table, they would store the list of videos for that user. List of videos for the user, which with the timestamp. Now, while I'm watching this video, let's say I watched video one, I'll add a row in user content table. Then I'll watch video two, I'll add a second row in the table. Then when I'll remove this table, or let's say when I remove this or when I am done with the video, I'll remove this entry from the user content table, or I would let's say make it some status so that it is easily queryable as well. So that's what they thought about it, making their data model simple, which was earlier complex, having different data models like Elasticsearch and Redis separately. This is the first thing. Then they thought of which kind of tool they should use now going forward, because with Elasticsearch and Redis, their cost was rising a lot. Then they have to think of something else. So they thought of another database which might be an easier option for them. So they vented about different options like maybe other NoSQL databases like Amazon DynamoDB, Cassandra, HBase, and all that. Then finally they rise to SkylaDB. SkylaDB is a new, or I won't say new, but it has a backing of a great community. They have a great architecture aspects like performance, operational simplicity, and the cost efficiency also. So it's a fully managed service. It's a cloud-based, fully managed NoSQL database as a service, which is offered at a lower cost as compared to the cost that they were paying for Elasticsearch and the Redis. So that's where their search ended on the SkylaDB. So this is what we will talk in the next video now, how they migrated from their current infrastructure to SkylaDB, and even using these two tables, how help them in terms of modernizing, or let's say supporting the same feature that they were giving their users on Elasticsearch and Redis, how they were able to support the same features in SkylaDB. And at the same time, we will understand from different aspects of architect lens, like how they did the cutover, how they did the routing from one from old to new infrastructure and all that. So that we will discuss in the next video. I hope you would have liked the video. In case you like the video or you are liking the content, Do like and share our content to others, and do subscribe to the channel as well. Thank you. Bye.